Okay. So again, I just wanted to pick up one or two little things that I missed yesterday with solving the quadratic equations. Okay, like I said, I'll just do probably like 2 problems here. Okay, so we'll call this like finishing up solving radical equations. Okay. And I'll go ahead and just jump right into an example here. Okay. Because there's a few other kind of like, I don't know, variations that we can see, okay? Yesterday, the radical equations that we solved, let's see, do I have those handy? I think I did. Put the paper down here, yeah. Okay, yesterday the equations that we solved, right, like for example this one, the square root was already isolated, so we just had to go ahead and square both sides to get rid of the square root and then continue our solving, right? Here for this one, right, we had everything over on one side, it was equal to 0, right, so we just moved one of these over by adding the root 2x minus 4 to both sides, right? And then we were able to square both sides. We had a square root over here, we had a square root over here, so they exactly canceled, we squared both sides, right? And then same thing here, this is a cube root, right? We kind of threw a little change in there with the cube root, but the idea again, just subtract the 7 over, okay? Then cube both sides to get rid of the cube root, and then continue solving as usual. So again, the big idea is isolate the radical, right? And then undo, cancel out the radical. Square both sides, cube both sides, raise both sides to the fourth, whatever that radical is. So in this case, right, we want to do the same kind of idea. So we want to get the radical by itself first. Is the radical by itself? No. What do we need to get rid of? The 2. So we'll subtract 2 on both sides. Okay, that cancels. We're left with the root x plus 10. And then x minus 2, they're not like terms, so we just rewrite x minus 2. Right? We can't combine them, so we just rewrite them. Now is the radical by itself? Is the square root by itself? Yes. Okay. How can we cancel out the square root then? What should we do? Square both sides. And again, when I say square both sides, I mean you have to square the entire side. So in other words, I can't just come in here and square just the x. And I can't just square the minus 2. I have to square the entire quantity. Okay? So what will this so we'll get to that in a second here. What does this left-hand side simplify to be? X plus 10, right? It's pretty straightforward. But then when I square x minus 2, remember, when I square something, what does that really mean? To do what? We're going to have to FOIL it. We have to multiply this thing by itself. So I'm really doing x minus 2 times x minus 2 here, which is going to require that we FOIL it, multiply it out and stuff like that, okay? So we're going to get a quadratic here, in other words. So x times x times minus 2. So we get x squared minus 2x, minus 2x minus 2 times negative 2. So we get plus 4 there, okay? You must FOIL this out. You must, okay? Students mess this up quite often, okay? When you square this quantity, right, you multiply it by itself, and so it FOILs out. Okay? You got to multiply it out. I'm going to combine like terms there on that right-hand side. Okay. Now, how do we solve an equation like this? What do we do from here? How do we solve an equation like this? What do we do from here now? It's quadratic, isn't it? And in order to solve a quadratic equation, we need to be equal to what? 0. So we have to move everything over to one side. So I'll subtract the x, and I'll also subtract the 10. Okay. X squared minus 5x minus 6. At this point, what strategies should we use to solve this quadratic equation? It's equal to 0. What options do we have? We could Could graph it. Okay, you could graph this and see where it crosses the x-axis. That's one option. Okay. If you wanted to graph, we could also. I mean, we could have graphed. Again, to solve by graphing, you can graph at any point in these steps here. Just graph the left-hand side, graph the right-hand side, find the point of intersection. So option 1 is to graph. Okay. What other strategies do we have here to solve a quadratic equation? Factor. If it factors, we can factor it. Yes. And then what else? We can only do that if we have a product, and this x squared is being subtracted the 5x and then subtract the 6. So that's why we want to factor first, CJ. If you factor this right into like a binomial times a binomial, then you can set each factor equal to 0. But it's not multiplying, right? Because that property you're trying to use there is called the zero product property. When two numbers multiply to make 0, one of those two numbers has to be 0. But if two numbers add to make 0, one of those two numbers doesn't have to make 0. Or if two numbers subtract to make 0, one of those two numbers doesn't have to be 0. It's just for the product. Okay? All right, we can factor. What if it doesn't factor, though? What do we do? Give up? What do we say? What's that? We could graph it. Okay. Yep, we could graph it too. But let's say without a graphing calculator, what's our last resort option to solve a quadratic equation? Quadratic formula. Yeah. Yep, the formula. Okay, negative b plus or minus the square root of b squared minus 4ac over 2a. Remember that I will give you that formula, right? There will be no point when you don't have that formula available. If I don't happen to write it on a test and you want to use it, please ask me and I'll be happy to give it to you, okay? You do not have to memorize the quadratic formula. You need to know how to use it, but you don't have to memorize it. Okay? So, does this factor? Yes. It does, okay? So, we need two numbers that multiply to make negative 6, right? But add to make negative 5, and that's going to be negative 6 and positive 1. Okay? And now we set each one of those factors now, like CJ was saying, we can set each one of those factors equal to 0. Okay? And so we get x equals 6 as an answer, and x equals negative 1 is an answer. Okay? Now, we've got to check these answers back in, right? So we're going to get the negative 6, the 6, well, actually, let me pause there first. Any questions up to this point about what we're doing? Any questions? Okay. So you can see why we did the quadratic unit before we did the square root unit, because there's going to be situations where we have to know how to solve a quadratic, right? Okay, there's a method to the madness, right? Method to the torture, maybe. Okay. We have to check these back into our original equation and make sure that they work. So let's plug in the 6. So it'll be 6 plus 10, which is 6 plus 10 is 16. What's the square root of 16? 4. 2 plus 4 is 6. And that x is going to be a 6 as well. So perfect. That worked. Check. Check. All right, let's try negative 1. What's negative 1 plus 10? 9. What's the square root of 9? 3 plus 2? 5. Is that equal to negative 1? No. So we must throw out this answer. Must throw out that answer. Okay. If you graphed here, you want to be careful. If you graphed the very first equation right here, I think you would have only gotten the one answer, the 6. Okay. So if you graphed the very original equation, you would have just gotten the 6. You wouldn't even have gotten this as an answer. If you would have graphed later on, like here, you would have gotten these two answers. Okay. So long story short, just always check your answers. Always check your answers back in just to make sure that they're going to work. All right, so questions on any of that? So I showed you this one again because of this step right here, where we had to do the x minus 2, that entire quantity squared there, to cancel it out. All right? Okay. I'm going to show you one more here, and you're probably going to hate me. But that's okay. Okay, a little anger. All right, here we go. Whoop. Let me write this. Okay. Why have the parentheses in? Did I get? Okay. I don't really need the parentheses there. I don't know why I put those in. Okay. All right. In fact, yeah, I think that's kind of confusing. I'm going to read it one more time. All right, let's try this one more time here. The cube root x minus 5 equals x plus 1. Okay, sorry. That's what I meant to write without the parentheses. Okay. So anyway, this is a radical equation, right? We've got our radical here. Right? Is the radical isolated? Is it by itself? Yes, right? There's nothing else with that radical on the same side, right? We have the x plus 1, it's on the other side there. So we can now go about canceling out that radical. What will cancel out a cube root? An exponent of what? 3. So we're going to cube the left-hand side, and we're going to cube the right-hand side. And that's why I kept writing in the parentheses there, because I knew we were going to cube it. Okay? Left-hand side is easy to figure out. What's the cube of the cube root of x minus 5? What does that simplify to be? Just x minus 5. Yeah, super easy, super easy. What does it mean for me to cube x plus 1? What am I going to do? X plus 1 times x plus 1 times x plus 1, right? So, hey, Jake, you're looking good.
So are you.
Oh, thanks, thanks. All right, are we going to record this thing here real quick?
I just need a quick picture of you too.
Okay, just a picture, that's it?
Yeah.
Oh, okay. You got it. Let me button this up here. I was running around a little bit this morning, so I'll be right back, guys. Sorry. Pause.
Yeah, your thoughts. What would you like to say? I kind of wondered if I'm back to this. I don't know. Looking good, Jake. We'll see you in set. Thank you.
All right. So yeah, we get to cube this thing out. Okay, so if you don't want to do that, I'm going to do it here so you can just kind of get the answer at the end, right? So to cube this out, right, we're going to just take 2 at a time. So I'll multiply these 2 together first. So we'll just FOIL it, right? So x times x, we'll have an x squared. And then x times a 1, well, that's 1x. And then 1 times the x, that's another 1x. And then 1 times the 1, that's another 1. And they still have that x plus 1 I need to multiply through there. Okay. I'll go ahead and combine like terms here in that multiplication that I did. So x and x makes 2x. X plus 1. And then last step, we will distribute. We'll distribute one more time. So again, anytime you're multiplying 2 polynomials together, right, the big idea is that every term in the one polynomial has to multiply with every term in the other polynomial here. So this x squared will multiply with the x in the 1. So x squared times x will give me x to the 3rd. X squared times 1 is 1x squared. 2x times x, 2x squared. 2x times 1, 2x. 1 times x, 1x. 1 times 1, 1. And then combine your like terms. 3x squared, and then 3x, and then plus 1. Okay, so there it is, multiplied out. Yay. But we're not done yet, right? Because how do we go about solving an equation like this? What do we want this equation? What do we really want this equation to be equal to? 0 as well. So I need to move the x over and move that minus 5 over as well, right? We're going to use a similar kind of strategy. We're going to hopefully get this thing to factor. Okay? Because we don't have a cubic equation, right? All right. So there's our polynomial. X cubed plus 3x squared plus 2x plus 6. Okay? So it's not quadratic, right? So quadratic formula, can't use it. You could graph it if you wanted to. Well, if we were going to graph it, we probably would have wanted to graph all the way at the very beginning, right? Because that would just be why do all this headache of work here and just go back to the beginning and graph that. Okay, find the points of intersection. So, does it factor? And if so, what strategy are we going to use? Grouping. Yeah, this groups. So I'm going to put it up here. And so we will group the first two and group the second two. Okay. From the first group, what can we take out? An x squared. From the second group, what can we take out? A 2. And we have an x plus 3. Okay. Does grouping work here with our results? It does, right? We get an x plus 3 and x plus 3 left over there. So we get 0 equals x plus 3 if I pull that out, and we're left with an x squared plus 2. Okay? And then just like we did in the last problem, we'll set each factor equal to 0. Okay, and I'll subtract 3 on both sides here. X equals -3. And I'll subtract 2 on both sides here. But I have x squared equals -2, so now what do I have to do to both sides? Square root. Yeah, square root. And it's going to be what? We're taking the square root of a negative number, so it's going to be imaginary. So we can forget about that one. So it's just the answer, -3. But we should check it back in just to make sure that it does work. So let's see here. -3 minus 5 is -8. -8, oops, well, yeah, -8. The cube root of -8 is -2, right? So -3 minus 5 is -8. The cube root of -8 is -2. -3 plus 1, -2. It checks. So that is our final answer right there. Wow, look at all that work. Isn't that great? Okay, you won't have one that difficult on your test. But I just wanted to show you can do it, right? Like, you were capable of doing this one. None of this here was that awful. It's just, it was a lot. That's all, right? But I mean, all this stuff is stuff we've done before, right? We're just putting a lot of pieces together, all right, to then be able to do something like this. So you can do it, right? You have the knowledge. All right, any questions? Those are the two that I wanted to show you. All right, thank you for humoring me. All right, and paying attention there. I think it was, you know, a good exercise to see those. And now we'll get into the review.